the salt can act as an acid or a base under certain conditions. So all salts are not neutral, like we may have said before. So some examples of salts would be NaCl. So salts that produce neutral solutions consist of cations. What's a cation? Positive ion. Of a strong base. So the first part came from a strong base. And the anion, which is our negative piece of a strong acid. So since it's neutral, it'll have no effect on the hydrogen ion concentration when dissolved in water. So our example is KCl or NaNO3. The first way is you can write a hydrolysis reaction. When we react HCl with water, or not HCl, KCl with water, what would we make? KOH and HCl. Remember, positive goes first. So of these, and this is a acid. What kind of acid? So strong acid, strong base is going to equal neutral. You could break it apart and say that this first part, always add hydroxide to it, and so this would turn into what? NaOH, and this would have come from, add H to this one, and we get what? This is a what? What kind of base? Strong base, and this is a, therefore it's going to be neutral. So without writing the whole equation, you could just do it shorthand that way. Salts that produce a basic solution are going to be formed when the anion of the salt is the conjugate base of a weak acid. So our Kb can be found using our expression that we talked about earlier, Ka times Kb equals Kw, to the hydrolysis reaction. All right, so of these two, which one of those came from something strong? So KOH, so think of it this way. So KOH is a strong base, right? So this is a strong base, which makes it neutral. Because the conjugate of a strong something is always neutral. So this potassium piece is neutral. All right, this one is from acetic acid. Okay, and acetic acid is a weak acid. And if it's a weak acid, then its conjugate will be weak base or basic. So we got neutral and basic. So overall, this is going to be basic. So let's look at this one. This is how, well, you'd have two types of problems in this unit. You'd have some where you're given a salt and you're going to have to ask to answer is it acidic, basic, or neutral. Okay? And you'll have some that are like this that you'll have to calculate the pH for. All right, so these aren't as bad because all you have to do is, one, look at this piece and decide which one is the neutral piece. We have Na. What are we going to add to the Na? OH, which is going to make it strong base. And if it came from a strong base, then it's neutral. So the key thing there is it came from a strong base. It's not a strong base, it came from a strong base. And anything that comes from a strong something is always neutral. F came from HF, so it's a weak acid, so its conjugate would be basic. Therefore, the salt is basic or something like that. So I have NaF, but it came from HF. So that gives you a hint like, oh, those go together. Those are conjugates of each other. So I'm going to ignore the sodium. You don't have to ignore the sodium, but your equation gets simplified if you ignore the neutral piece. So we're going to write our fluorine. And what charge is fluorine going to be? Negative, because we took off the sodium. And is fluorine acidic, basic, or neutral? Basic. We know it's basic because it came from a weak acid, and so its conjugate would be basic. What do you have to react bases with? Water. And so what do we produce? HF and hydroxide. Okay, if we put the sodium in with fluorine, then we would have produced sodium hydroxide, which is fine. You would have just had to realize, like, oh, well, if I have sodium hydroxide, my sodium hydroxide would dissociate 100%, and I'd be left with hydroxide, which is what I need to find my OH, and then I can get my pH. water. This is going to be our 0.3. This is 0, and don't work ahead because there's one more glitch. Was this an acid or a base? A base. This is a basic reaction, right? HF or F is a base. So we're going to have a K what? B expression.
Thank you.
We get that? Do we have a KB value? Only have KA. So all we need to do is say KW is equal to KA times KB. And so 1 times 10 to the negative 14 over, 7.2 times 10 to the negative 4 is equal to your KB. So KB is equal to what? Can we ignore the minus X? Yep. That Ka is pretty small. And so X is going to equal our OH concentration. Make sure you're writing that. So then POH equals negative log of that, which gives you so opposite of that, salts that produce acidic solutions are going to come from positive ions that were conjugates of weak bases. This one you probably wouldn't see that often, or a highly charged metal ion. Like our aluminum chloride. So aluminum is a +3, and so that is a highly charged metal, so that does produce or makes a weak acid. The same way, by saying this one comes from NH4OH, or at least we can say that's what it came from. And so is this a base or acid? Base, what kind of base? Weak base. So that's a weak base. And so if it's a weak base, then it's going to make NH4 acidic, because they're always opposites. It's conjugate. Its conjugate's always the opposite charge, or opposite acidity basicity. All right, this one comes from, which is a strong acid, and so its conjugate would be neutral. So again, this is my conjugate. So only this one is affecting it. That's the neutral piece. Okay, and aluminum chloride you can do it the same way by just saying this came from aluminum hydroxide, so that's a weak base, so it's going to be acidic, HCl, strong acid, neutral. That's not completely true, but it would work for figuring out if it's acidic or basic. KB4 NH3, so which one of these do we think is probably the thing that matters? NH4, so we can ignore that and write our NH4, what charge? Plus, and is that acidic or basic? Acidic. Do we need to add water to it? Nope, we can just break it apart. And what is it going to give off? And what else are we going to produce? Set up your your chart. This one is 1. And what can we use that KB? Nope, we need to find the, so do exactly what we did a second ago. 1 times 10 to the negative 14, so always going to go on top. All right, so do we have the Ka? Yep. And make sure that you wrote your equilibrium expression. I said negative what? And what does x equal? H plus. So if I negative log H plus, you get pH, and pH equals 5.3? 5.13? Question on it. All right, so what if you have an acid? What if you have a salt that could be an acid or a base? As in they both came from weak things. So you're like, well, this one came from a weak, this one came from a weak. You're going to look and see if your Ka is greater than your Kb, in which case then it's acidic. If the Kb is greater than the Ka, then it's basic. If your Ka equals the Kb, then it's neutral. So, and those are of the conjugates. So those are the Kb's and Ka's of the conjugates, because those are what's actually reacting. All right, so for example, it says NaF or NH4F, would that be acidic, basic, or neutral? They gave me the Kb for NH3, so that's this one's conjugate, right? And HF, they gave me the Ka for it. So NH4, its Ka would be what? How would we solve for its Ka? Over. Yep. So solve for the Ka of NH4 plus. And I think actually we did that on the last problem. Was it 5.56 times 10 to the negative 10? NH3 is like our main weak phase. And then HF, or our F negative, we need the Kb for it because it came from a weak acid. So this must be a base. We do the same thing, 1 times 10 to the negative 14 over that. So what's the Kb? Times 10 to what? So which one of those is bigger, negative 10 or negative 11? Negative 10. So our Ka is bigger than our Kb, therefore it is stronger and it's acidic. What is this? So we're using that equation of Kw is equal to Ka times Kb to find the Ka and the Kb of my conjugates. My conjugates were NH4 and F negative because these are not what's over there. Like they're conjugates of what's over there, but they're not what we have. So I use this equation to say, well, 1 times 10 to the negative 14 over this one gives me this was a base, so it gives me the Ka for NH4 plus. Then I do the same thing, 1 times 10 to the negative 14 over this one, which is an acid, will give me the Kb for my base. All right, so it says predict whether the following salts will be acidic, basic, or neutral. So I say NH4, well, that came from, and I look over here, it came from a base. Oh, it came from NH3, so that's my Kb for that base. And then I look at the next one. It's easier on a test or a quiz because I would have already given you all these values. If they were weak and weak, I would have to give you the values. If one of them was strong, then I don't have to give it to you anymore. We're figuring out if those are acidic, basic, or neutral. So you should be able to do at least A through C. Because for that first one, do either of those come from a strong thing? So if they don't come from strong, then you need these. So we can figure out which one's stronger. If one of them comes from a strong, though, then we're like, yeah, you don't have to even care about these. All right, so letter A. What is letter A? Neutral. How do you know it's neutral? because Ka would equal Kb. So we didn't have to calculate our Ka and Kb of our conjugates because if these were equal, then the others have to equal. All right, this one, what one is stronger, Ka or Kb? Ka is bigger. Oh, no, Kb. Basic. Because, remember, it's the conjugates. This one, or you can also think of it another way without actually calculating it. Which one of these is stronger? Ka is bigger, right? So its conjugate is going to be stronger because the stronger the acid, the weaker its base. So if this is a stronger acid, oh, we're looking at these two. No, what? We're looking at these two. Ooh, okay. Life is good again. All right. Which one is stronger? Kb. And so if our base is bigger, our conjugate acid would be weaker. So the stronger the base, the weaker its conjugate acid. This one is a very weak acid, so its conjugate would be stronger. So you could actually calculate it and get your Ka for this and your Kb for this, but your Kb is going to be bigger because this is a weaker acid. So out of these two, this one is weaker, which means its conjugate would be stronger. I'll say that again. So out of these two, this one is weaker. And since this one's weaker, its conjugate, which is an acid or a base, what would its conjugate be? A base, because this is an acid. So its conjugate would be stronger, making this a basic solution. You can calculate it out if you want, but that's the reason why, and it will always come out that way. You're looking at its conjugate. Because we can't look at these because this isn't what I have. I don't have an H3 and HC in there. I have their conjugates, which are going to have opposite values because it's 1 times 10 to the negative 14th over that. All right, and this one, do I have to look at the chart? No, because which one of those can you ignore? The SO4. This one, though, was a tricky one because, well, what should it be? Anyone? It is acidic. Because it came from, well, it doesn't really, but if it came from a weak base, if you're just looking at it, aluminum hydroxide, it doesn't come from aluminum hydroxide. But if you did it that way, then you'd say, oh, well, aluminum hydroxide is a weak base, so it must be acidic. The real reason is this is a highly charged metal. And highly charged metals do have a Ka, and we actually do have aluminum there. And so that's why it's acidic. Because this is a highly charged metal. And highly charged metals, remember it said highly charged metals or conjugates of weak bases are going to be acidic. So they did give us the Ka for this highly charged metal, and I do still have aluminum. It doesn't look exactly like this, but when I put it in with water, it will do this and turn acidic. Well, aluminum has a +3 charge, so +3 charge, +4 charge. Those are highly charged metals. All right, so over here on this one, first figure out all the ones that have something strong in them. I will say that all of them have something strong in them. So do we need to look up any of the values for these? No, so scratch out your neutral piece of each of them and figure out if they're acidic, basic, or neutral. If you scratch out both pieces, then it must be neutral. Guys, all right, so we can ignore the chlorine on that. So we're left with iron, which would be acid or a base. So this came from a weak base. So our conjugate, iron, is acidic. Chlorine came from HCl. So let's break it down. Redo it. So this one we can say came from iron hydroxide, and this one came from HCl. Are we all with me so far? Yes. All right. So HCl, is that a strong acid or a weak acid? Strong acid. How do I know that's even an acid? Because it starts with H. This one is a base. What kind of base is it? Weak base. So back to what we actually have. If this is a weak base, its conjugate is acidic. And if this is a strong acid, then its conjugate is neutral. Which one do we not care about? Neutral, which leaves us acidic.
Make sure. The conjugate of the weak base will be weak acid, right?
Yes.
But it's only because we cross that out that it is acidic. Because if the other one wasn't neutral.
Then we would have to look at the Ka, Kb values. So if this one was, let's say this was a weak acid, then this would be basic. And they were like, oh, well, that's an acid, that's a base. Oh, we need more information. We're going to have to look at the Kas and Kbs from these things.
I understand.
Okay? Only because one's neutral does that lower how much work we have to do. All right, so on E, which piece can we ignore? Na. Are we good that we can ignore Na? Because that came from a strong base. So don't care. H2CO3, that is a weak acid, so its conjugate is going to be basic. So altogether, this should be a basic salt. Good there? What about F? Which piece is neutral? Both of them, because KOH is strong and perchloric acid is strong. Therefore, it is neutral. Good there? All right, NaHC2O4. Which piece can we eliminate, Brandon? Sodium, because that came from a strong base. Our other piece came from oxalic acid, H2C2O4. Is that a strong acid or a weak acid?
Weak acid.
That's a weak acid. And if it came from a weak acid, then its conjugate, HC2O4, is basic. And the last one, which piece can we eliminate? Bromine. NH4 came from NH3, which is a weak. So it's acidic. So all these that I'm saying they're acidic or basic, these are all weak acids and bases. Salts are never a strong acid or a strong base. Because the only way to be strong is if it's one of those 7 strong acids or our strong bases. Okay? All right, one more calculation and then we're done with this section. All right, it says calculate the pH of a 0.1 molarity solution of NaCN solution. All right, so this one did not give you your value. So we have to look on this chart. So you tell me which one we're looking at. Which one? Because which one can you ignore? So you need to look on the chart and find HCN. It should have a Ka of, okay? What will that salt be? Acidic, basic, or neutral? What is CN negative? So HCN is a acid, so CN is going to be a base because they're conjugates. If this is an acid, that has to be a base. And so if it's a base, what do we have to react it with? Water. What do you make? HCN and hydroxide. You should also always see what your thing is up here, probably on the product side. Like see how I have CN and then on the other side of HCN. All right, so go through and solve this one. All right, so we had 0.1, didn't care, 0, 0. K, what expression? KB expression. So KB is equal to what?
2.04.
Times 10 to the negative 5.
And so X is equal to our concentration of what? OH, which is equal to 1.43 times 10 to the negative 3. So POH is,
Yes.
and pH is 14 minus that, giving